These are the 4 types of representations that we have for functions and relationships. I'm going to zoom in now. We're going to speak about each one. All right. The first one is we represent relationships and functions using an algebraic formula. All right. That's when we set our output, which we usually use y to represent. Y is equal to, and in this case, it's 5x plus 20, which means you'll say 5 times x, and then you will add 20. There's actually five ways to represent function, but we'll speak about the 5th one just now. Okay, so this is way number 1 by ways of algebraic formula. Number 2 is the flow diagram, which was our first lesson for this section. Once again, we have 2 sides. My left-hand side are where my input values are located, input or x values, and my output values will then be located on the right. In the middle of my flow diagram is the function. Okay, so what are we doing with the input values? It's the same one as the first one. So it tells you we will first multiply by 5, and then we add 20. Okay, so far we have algebraic formula and a flow diagram. Way number 3 is the table. Okay, the table was our last lesson last week that we had. In this case, we also represent our input and output values just at the top and at the bottom. So my input values are all located at the top because those are the values that I pick. Okay, then after you have done the operation, as you can see, our formula is given over here. After you've done the operation, your output values, you will locate at the bottom. And the final one, which we have not spoken about yet, and we are going to introduce today, is by means of a graph. Now, I said there's technically 5 of them. The 5th one would be by means of words, okay? If you look here, what I said to you is you first multiply by 5, and then you add 20. That is using words to describe a relationship between the variables. Okay, so these are our 4 ways. So today we're going to start with how to use graphs to represent functions. Okay, first things first, I am going to discuss what is on our screen right now. Now, this is called a Cartesian plane. So this is a Cartesian plane. Okay, first thing you have to notice is this is basically 2 number lines. 2 number lines. Okay, I have my horizontal number line, which we call my x-axis. Okay, this is our x-axis. And my vertical number line, which I call my y-axis. All right. Now, if you look at this number line, they all start from the middle, and that part that we call the middle is the origin. That's where the 0 is. That's where we start counting for both number lines. So we have our 0, and going to the left of my x-axis are all my negative numbers. So these are all my negative numbers going left. Not sure why I felt the need to color that in. And going right on my x-axis are all my positive numbers. So if you look here at the numbers that are filled in, 1, 2, 3, 4, blah, 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 blah. Now, does anybody know why there is an arrow over here at the end of my axis? Why do we have an arrow at the end of the axis? We have counted up to 9. There we go, because this goes up to positive infinity. So it goes on forever. I don't know why I'm writing with such a thick pen. It looks terrible. So this positive infinity, which means it goes on forever. And in the same way, if you look at my negative side, this goes all the way to negative infinity. Okay, so it will keep getting smaller and smaller and smaller and smaller and smaller forever and ever and ever. Now, if you look at the y-axis, we have the same type of concept here, except my positive numbers are all going upwards. So if you look here, 1, 2, 3, 4, we are counting up. So that means going up is my positive infinity, and going down will be my negative infinity. Okay. Now, these 4 blocks that are created by my 2 axes are called quadrants, okay? Everyone who will be here when we are doing trigonometry will appreciate this word. These are called quadrants. We always start counting at our top right, and that is quadrant number 1, and we go anti-clockwise. So we have quadrant 1 located on our top right, quadrant 2, top left, quadrant 3, the bottom left, and quadrant 4. Okay. Now, if you look at the brackets here, they tell you what my symbols will be for my coordinates. So in quadrant 1, both x and y will be positive. Okay, they will always be positive there. That's because in quadrant 1, we are going to the right of my x-axis and to the top of my y-axis. So that's where all the positive points are. In quadrant 2, my x will be negative, but my y will still be positive. Quadrant 3, both will be negative, and in quadrant 4, it's the other way around, where my x is positive, but my y is negative. So quite literally, you either look, did I go left or right? And that will tell you if it's positive or negative, and then you just count how many times you went. The only thing to remember is when we write coordinates, okay, you always start with a bracket. You write your x coordinates, a semicolon, your y coordinates, and you close your brackets. Now, this is a coordinate, okay? I don't want to see you guys writing it with a comma or a colon or a full stop and leaving out my brackets. That's not acceptable. This is how we write coordinates at all times. All right, so let's write coordinates of a few of these over here. Actually, let's start with the exercise. Let us start with the exercise, okay? Tell us which point is located at each of the following coordinates. Now, can anyone tell me what is wrong with the coordinates that you can see? I just told you right now what I expect when I ask for coordinates. What is wrong with these coordinates that they've given us? Nice, Mune. They are using a comma, and it's supposed to be a semicolon. There we go. Fix it quickly before I have a heart attack. Okay. There. Now, first point is -9 and -1. Okay. Which point is located at -9 and -1? That would be D. So we start in the middle. We said the first coordinate is always your x. That means the -9 means you go to -9 on your x-axis. And then it says go -1 on your y-axis. So you're going down 1. And that would be point D. Nice. Number 2, +4, +7. +4 and +7, and that is in fact point Q. Number 3 says -3 and +5. So 1, 2, 3, and then going up 1, 2, 3, 4, 5. That is point J. Number 4, +7 and +3. So we're going all the way up to 7 on the x-axis, and then we're going 1, 2, 3 on my y-axis. So that is which point on the Cartesian plane? Nice, guys. That is point T. And then number 5, -6 and +2. -6, +2, there's -6, and then I'm going up to 1, 2, That is point V. Then we have the next one, -2 and +8. -2, bloop, bloop. +8, I'm going up 8. 1, 2, 3, 4, 5, 6, 7, and 8. That is point F. Number 7, +7, -6. +7 over there, and then we're going down 6. That is indeed point E. And the last one, -2, bloop, bloop, and -3, 1, 2, 3. That is point N. Nice, guys. Beautifully done. Okay. Now, this time we're writing the coordinates of the points they are asking for. The first one says, write the coordinates for point M. Point M is located on the side here if you can't see it. Here is point M. What is my coordinates for point M? Remember, we're starting with the X and then with the Y. So on the X-axis, it's located at point 9, right at the end. So you can go down until you touch the X-axis. And then if you go across until you touch the Y, that is 2. So my point, I'm glad you all writing it correctly, is 9, 2. I'm just going to do the odd numbers. So number H, well, number 11, point H. H is right over there. What is the coordinates of that? Or what are the coordinates for point H? H is -7 and 5, and that would be correct. Whoop. -7, 5. Z is on my X-axis. So what are my coordinates for Z, which is on the X-axis? Nice, guys. If it did not move up or down, then my Y coordinates is 0. So that would be -2, 0, and finally P. Coordinate P is, let's see, we moved 1 and then 1, 2. That is indeed 1 and 2. Okay. Now for the last one, you just have to rely on me to plot them. I'm just going to plot 2 of them. Okay. Point X says -7 and -1. So I'm starting in the middle. Will I be moving left or right for -7? Will I be moving left or right? Left 7 times. And then with -1, am I going up or down? I'm here right now. Down how many times? Once. So my point is located over there. And they've told us that this point will be named X. Okay. And then let's do K, +3 and -9. I'm starting in the middle. Am I going left or right? How many times? Right, how many times? 1, 2, 3. So I'm here currently. And then -9. Am I going up or down? Oh, am I going up or down for -9? I'm going down. How many times? 9 times. So I'm going all the way down over there. And that is my point K. That is the point K. Okay, thumbs up, thumbs down on how this Cartesian plane works. Do we all understand? Have we understood everything that I have done so far? Wonderful. Okay, I see thumbs up. Beautiful, beautiful. Tali, where did I lose you, darling? Raise your hand so that I can unmute you. There we go. Hello, Charlie.
Hi, ma'am.
Where did I lose you?
Ma'am, ma'am, I understand basics, but I think I don't understand the done it.
You don't understand what? Your network is shaky a little bit.
I feel like I don't understand it properly because we have never done it before. So,
Okay,
but
but
I
has
understand the
everything I've
basics
said
of the
made
tools.
sense?
Yes, ma'am.
Okay, then just hold on, okay? Don't anticipate failure. Let's just do some more examples and you'll be fine. Okay, Charlie, don't worry too much. All right. If everything I've said so far makes sense, then you're all good. Okay, now let's see. So in our previous lesson, we were matching equations with tables, and now we're going to match tables with graphs. Okay, now the best way in which to do this is to find coordinates on the graph and try to match them to the tables. Okay, so I'm going to start with graph A. We only have one coordinate in graph A, and it's all the way here. What is my coordinate for graph A? Let's start with the x-axis. Did we move left or right in any way for this point? Did we move left or right in any way? No, so then my x-coordinate is what? If I have not moved left or right at all, then my x-coordinate is nice. It is 0. My y-coordinate, have I moved up or down? Down. So what is my y-coordinate for this graph? It is -1. Okay, there is only one table that I'm looking at that matches a coordinate like that. And which table is that? 0, -1. That would be table A that goes with graph A. Wonderful. We've done graph A. Okay, I'm going to move down to graph C. We have 2 points in this case. Let's start with the green point. What are my coordinates for the green point? We have not moved left or right. So what is my x coordinate? Those are not coordinates, guys. Coordinates means you put graphs, you put brackets, and you put my x and y coordinates. Okay. Have I moved left or right for x? At all? Look where the graph is. Deboho, what don't you understand, my darling? Please ask a specific question, then I can help you. Guys, look at where my point is, right? Look, it's on the y-axis. So did I move left or right in any way? If it is on the axis, did I move at all? Listen to my question, guys. These are 2 separate coordinates. Do not look at this 3. Okay? If I have, okay, I'm going back over here. If my point is here, the one I just drew there, okay? Maybe I shouldn't have drawn it in a dark color. Let me draw it like that in red. If my point is over there, did it move left or right in any way? No, guys. So what is my x coordinate? 0. Do you see that the point I just drew is the same as the point on graph C? Do you guys see that? It is on the y-axis, so it did not move left or right. Yeah, guys, you need to be careful. These are two separate points. They're not the same point. So then my x coordinates, my x coordinate for that point is what? Because we just established that it didn't move. This one over here. What is my x coordinate? It is 0. And then my y coordinate, we can see it moved up. So what is the y coordinate? It's definitely not 0. It is. Nice, Senyani and Le Achilwe. Nice, guys. It is 2. Now we move on to the next point. Remember, if they're not at the same place, they are two separate points. Now I move to this one. Did I move left or right in any way? We're on the blue point. Did I move? I moved right. So what is my x coordinate for that point? Nice, guys. It is 3. Did I move up or down in any point? In any way, excuse me. Now I'm saying point for everything. No, I haven't. So what is my y coordinates then? It is 0. Nice, guys. Is there a table that cooperate or corresponds with these 2 points that I just drew now? Look at your graphs carefully. Is there any table that corresponds with 0, 2, and 3, 0? Indeed, that is table C. So that means graph C goes with table C. Okay. Let's go to graph D. They already gave us the coordinates for graph D. Is there a table that corresponds with that coordinate? They already gave us the coordinates for graph D. Which table corresponds? Table B. So this is graph D. Now for graph B, none of those points will be located in the table. Okay, so how are we going to make sure that those points are actually valid? Does anyone have an idea of how we would make sure that graph B is a match for table D? Think of the previous lesson. What were we doing in the previous lesson? Anyone? No one knows? Okay, let's look here. Okay, I have an input. No, I have an input. Let's look at my table. Now, I have an input of 2, 4, and 5. So to go from, nice, to go from 4 to 5, what did I do? The outputs. We're looking at the outputs now. From output 4 to 5, I added 2. Now, we have skipped one of the outputs over here. Do you guys agree? We have skipped one of the outputs. So if I had, let's say I had 3 here. Input 3. Okay. If I go from 8 to 4, before I even put that 3 there, going from 8 to 12, how much did I add? I added 4, which means going from 8 to 3, I would have had to add 2. Nice, guys. Guys, we are answering a bunch of random stuff. I don't know what's going on. Let's follow. Okay, I don't want to lose anyone. So then for number 3, for input 3, what would my answer have been? What would my output have been there? It would have been 10. Okay, now we have plus 2, plus 2, plus 2. What is that plus 2? It's our multiplier. It's our multiplier 2. So then I'm going to test it with the first one. Okay, if I say 2 times 2, that is 4. Is that the outcome that I want? No, so what do I still have to do? Plus 4, and that's going to give me 8. Let's check that it works with another one. 5 times 2, that's going to give me 10. And if I add 4, it gives me 14. Is that the outcome that I wanted? Yes. So what is my equation for table D? Table D, nice thing, it is y is equal to 2x plus 4. Now we have an equation, okay? I am going to substitute one of these inputs. I'm going to take this input and substitute it and see if I get the correct thing. Okay, what is the coordinate? Let's start with the coordinate first. Did it move left or right in any way? Did it move left or right in any way? Yes, it moved left. So what is my x coordinate? -2. And my y coordinate, it did not move up or down, so my y coordinate is 0. So I'm going to take that x and I'm going to substitute it into y is equal to 2x plus 4. Okay, y equals 2 times -2 plus 4. What's 2 times -2? -4. And if I add 4, that is a 0. Is that the output we wanted? Yes. So does graph B, in fact, match with table D? Yes. See, guys, this is what I meant with crossing through multiple representations. Thumbs up, thumbs down with that one. It was a little bit long. Are we all happy with how that one went? Give me a thumbs up if you understand, or a thumbs down if there's something that is still confusing you. I know it's making our brains go round and round and round and round. It's a lot of fun. All right, thank you for your thumbs up. Okay, now we're going to the representations of a flow diagram and an algebraic equation. Okay, so here we have my algebraic equation. It's been given. And they say fill in the flow diagram using the given information. Now it says fill in this flow diagram for the following values. Those values that have been given, are those inputs or are they outputs? Oh, Mutibang, I didn't see your thumbs down. Mutibang, raise your hand, please, and ask a question so that I can help you. I'll just wait while I write this. There we go. Yes, Mutibang.
Ma'am, I don't understand. Is it that the y it must move left and right?
No, no, no. The x moves left and right. Where's the x-axis? It's the horizontal one. Do you see?
Yes, ma'am.
Yes. So the x is the one where you check left and right, and the y is the one where you check up and down. But Motibang, if it is here, if my point is on the x-axis there, did it move up or down at all?
No, ma'am.
That's what we were talking about. So if it didn't move up and down at all, that means my y coordinate is what?
0.
0. Do you see what I was saying?
Oh, so if it
Yes.
doesn't move up and down, it's 0.
Yes.
Now I understand. Thank you, ma'am.
You're welcome. That is a beautiful question. I know there's someone who might have been confused as well. Okay, guys. Wonderful. So in fact, it is my inputs. These are my inputs and they are located on the left, whereas my outputs are located on the right. So I'm going to fill in my inputs quickly. So I have a -16, -4, 0, 3, and 8. Okay, once again, we said in these blocks is my function. So we're going to speak about what are we going to operate on, my operations. So based on the formula over here, what am I going to fill in the first block over here? What's the first thing we're going to do with x? Look at that formula that is written over there. What is the first thing we're going to do with the input? Divide by 2. So in here, I'm going to fill in divided by 2. Remember, we do not write anything to do with x over here. It is purely operations. Okay? So I can't write over here now x divided by, no, I just write divide by 2. Then what happens after divide by 2? It is plus 1. Okay, now let's fill in the rest of this. Okay, first one, it says y equals x divided by 2 plus 1. My first x is negative 16 divided by 2 plus 1. What's negative 16 divided by 2? Indeed, it is negative 8. And if I add 1, that means my output is negative 7. Nice. Negative 7. Next one, I have negative 4 divided by 2. What's negative 4 divided by 2? That is negative 2. And if you add 1, what is my output? Negative 1. That's negative 1. Next one, 0 divided by 2. What's 0 divided by 2? That's just 0 plus 1. That is 1. Oh, you guys are going very fast. Remember, if we're going too fast, just stop us. Okay, then I have 3 divided by 2 plus 1, 1 comma 5. And if I add 1 to that, that is 2 comma 5. Or if I want to write it as a fraction, how will I write that? How would I write that as a fraction? The other way around, Alice, but yes, 5 over 2. 5 over 2. And my last one is 8 divided by 2 plus 1. What's 8 divided by 2? That is correct, guys. That is 4. And if I add 1, my output is 5. And we are done with this question. That went very fast. Let me zoom out for you guys who want to take screenshots. Hopefully everyone is still with me. Hopefully everyone is still with me. Okay. Moving on. Now, we're going to go from using a formula to filling in a table and its coordinates. Okay, so this is in preparation for the lesson on Thursday. We will be doing graphs on Thursday, purely graphs. Okay, so we're going to use this formula over here to find our coordinates as if we would be plotting a graph. Okay, so first thing is first, once again, these are my inputs. So are they going at the top, in the middle, or at the bottom? Where are they going? At the top. Nice. So I'm going to fill these in. That's a negative 8. A negative 4 is 0, 1, and 16. And we just happen to have an extra one over there. Okay. Now we need to find my outputs. Where are my outputs going to go? In the middle or at the bottom? Where are the outputs going to go? Nice. They're going to go in the middle. Now let's get going, okay? First one is 16 divided by negative 8. What is my output for that going to be? Nice, Senyane. That is negative 2. So output number 1 is negative 2. All right. The second one says 16 divided by negative 4. And my output for that will be a negative 4. So I'm going to write it down here. -4. Third one is 16 divided by 0. And what is my answer for that, guys? Oh, be careful. Nicely, Achille. This is undefined. You cannot divide any number by 0. So this is undefined. And then we move on to 16 divided by 1. And my answer will be 16. And finally, 16 divided by 16. And my answer is 1. Great. Now let's write our coordinates. Give me the coordinates of the first point correctly. Nice. That is a -8, semicolon, -2, and I close my brackets. Second one, coordinates. Nice. That is my -4 and -4. Remember, we always write them correctly. 2 brackets and semicolon. The third one does not have coordinates, so I'm going to say, well, I was going to say NA, but Maureen has given us an idea, but I was going to just say not applicable, because how do you plot undefined, guys? You can't, right? So I'm just going to say NA. There is no coordinate over here. The next one, 1 and 16, and my last one, 16 and 1. Beautiful. Okay. Another one. Okay, we're back to matching equations. This time we're matching equations with graphs again. All right. Once again, what I suppose we should do is take a coordinate, substitute it, and see if it matches. So before we do that, I would like you to tell me what my coordinate is for the yellow point I just highlighted right now. The point I just highlighted, what is the point for that? What are my coordinates for that? Indeed, that is 1 and 3. Yes, Pamanda. Hello.
Ma'am, can I ask one question? So will these graphs be more complex in trigonometry?
Yes, they will.
Yeah.
You're going to have your sine graph, which looks, if this is your axis, oh, if I could draw axes, that would be fabulous. Your sine graph looks something like that. Your cos graph looks something more like that. And your tan graph is a bunch of these things going down. So it is more complicated. Okay. It's very fun though. Fun times. Okay, so that is my coordinates. So now I'm going to substitute this point. I'm going to substitute 1 and see if I get an output of 3. Okay, let's start. I promise you it's fine. You'll love it. You will absolutely love it. So for the first one, it's y equals. Okay, let me disable annotation before I go anywhere. There we go. Okay, back to this. First graph is y equals 1 plus 2, which is 3. Does that match with the output we want? Yes, so we don't even go far. And this matches with equation A. A, B, C, D, E, F. Has anyone found the next one yet? Has anybody found the next one? No. Okay, let's see. Okay. Highlighted a point there. What are my coordinates for that point? Coordinates for the point, -2 and 2. Okay, so if I am going to multiply anything by a half, I'm definitely not going to get full number, ne? Especially not if my point is -2. So B and D, I can already eliminate. You guys see what I'm saying? You need to work smarter, especially in an exam. If you don't have a lot of time, right? So B and D are definitely out. Let us check out the rest of them. So let's try with C. C is x minus 2. So that would be y equals -2 minus 2, which is -4. Is that the outcome I wanted? No. So C is definitely not the right one. Let's go to E. Y equals -2 minus 2. Do you guys see the difference between C and E? I need to highlight this difference quickly. This negative is this one over here. All right. Then this one was the one from the point. So you have to say -2. Whereas C didn't have a negative in front. So it just has one negative that comes from the coordinate itself. Do you see that, Deboho? I need to make sure you guys understand the difference between C and E. So the negative that maybe I shouldn't highlight it in yellow because there's yellow everywhere here. Let me find a special color for it, highlight-wise. Boom. So this negative there is the one that's in the formula. And then the negative inside the bracket, it's the one that's from the coordinates, which is over there. Okay, so this will be +2 minus 2, and this is 0. Is that the outcome we wanted? No. So E, C, and E are out. Next, G, Y equals -2 plus 2. This will give me 2 plus 2, which is 4. Is that correct? Senyani already found my correct one. Okay. Says F is correct. This will be -2. Whoop, I forgot to write my equals. So this will be y equals -2x minus 2. Okay, what's -2 times -2? -2 times -2. Be careful, that is +4. And if you minus 2 from that, you get +2. Does that match up with my coordinates? Look carefully, Leachilwe. Remember, it was -2 and 2. So yes, it does. So then graph number 3 matches up with equation F. Okay, guys. So you guys need to work. You see how fast I just worked now. You guys need to get used to working like that so that you finish your exams nicely and confidently. Okay, but you guys are working fast because you're the ones giving me the answers. So you guys must get used to that pace. You must keep it up. I like it. Okay. Nope, we're not going to do those ones. Let us do this one. It says fill in the table and then find the equation. Okay, so if we're going to fill in the table, we need to see what's going on. Okay, please screenshot as fast as possible. All right, there we go. From here on out, screenshots will be at the end if you miss it. Okay, I'll go back to them at the end of the lesson. All right. So now I need to zoom in over here. I'm going to name these coordinates so that we know what everyone is talking about. A, B, C, and D. Okay. Now, I have a table over here that we need to fill in using the graph. And then they asked us to find the equation. Okay, so we're using actually 3 types of representations now. We're using a graph, a table, and an equation. Now let's get going. Coordinate A. What are the coordinates for point A? Excuse me, point A. What are the coordinates for point A? Point A is all the way here. It is 2 and 7, and that is correct. So point A is 2, 7. Remember, you can zoom in on your device as well if you can't see properly, but I did try and zoom in a little bit here. Point B, what are my coordinates for point B? Nice mine and senyanu. It is 1, 2. All right. Point C. Point C, nice senyane. I'm glad you guys don't confuse the 0 coordinates about where it goes. So it is 0, -3, and point D is -1 and -8. -1, -8. Okay, now let's fill in my X and Y for my input and output. So I'm going to put your input and I'm going to put your output. Okay, what are my inputs from these coordinates? The first one, what is my input for the first one? 2, and for the second one, 1, and for my third one, 0, and my last one, -1. Nice. My output for the first one, 7 for the second one, a 2, third one, -3, and last one, okay, I don't know what happened there. It is -8. Right, now we need to find the formula here. Remind me again, when we find the formula or the equation, do we look at our inputs or do we look at our outputs? Which of the two do we look at when we are finding an equation? We look at the outputs. Now look at them. What is happening between the outputs there? How are we getting from one to the other? Nice, guys. From 7 to 2 is -5. 2 to -3, -5. -3 to -8, -5. Okay. So then I'm going to add a -5 here, and we're going to have to work it out when we're done. So then -5, oh, you guys are way ahead of me. -5 becomes our multiplier. Now let us find our formula. So I'm going to start with the first one. -5 times my input of 2. What's -5 times 2 here? -5 times 2 is -10. Now, how on earth am I going to get to 7? +7. Nice, Senyani. I have to add 17 and I will get to +7. Let's test it with another one. Okay, let's test it with another one. Okay, I'm going to say -5 times 1. What does that give me? -5. Okay. And if I add 17, okay, we made a mistake here, guys. What is my mistake? Something is off. Something is off here, guys. Not again. This always happens to us. Oh, they're other way around again. Gosh, they're the other way around again. So actually, no, I'm gonna rewrite that. Remember, we go from smallest to biggest. What's going on here? We're going from, my table was supposed to be filled in from smallest to biggest, not biggest to smallest. So actually, we are going that way. My table's going that way because it's supposed to start with -1. Let me write them the correct way around as to not confuse us. 0, 1, 2. Whew. So -8, -3, 2, 7. So we're not minusing 5. What are we doing? It's not a subtraction of 5. It is a addition of 5. We need to make a very big note for your teacher and everyone else in the world, okay? These must go in ascending order. Always. Okay, so my multiplier is actually +5. Is +5. Whew. There we go. Now it's going to make sense. So then if I say 5 times 2, that's going to give me what? 5 times 2 is 10. And what do I have to do to get to 7? I have to -3, and that's going to give me 7. Whew, now let's try it with another point, just to make sure that we're fine, okay? I'm going to say 5 times 0. What's 5 times 0? A 0, and if I subtract 3, -3. Is that the output we wanted? Yes, so what is my formula? Y is equal to 5x minus 3. Whew, I don't even want to work this guy out anymore. I'm traumatized.